Well there, buddy, what are you doing?
I'm just burning my hopes and dreams.
You know when you burn that paper, it's changing chemically. Because you see, it's producing energy.
What? Oh, that's a chemical change?
Yes.
Why so?
Because it's a chemical change, because a new substance is formed. You see, that black stuff right there, that's ash, not paper anymore. So therefore, it's a chemical change. A chemical change is when a substance gets changed somehow, and it becomes a new substance.
Stranger, why are you telling me this and why are you in my house? Oh wait, so okay. Is that the only thing that can happen to a substance? Is there anything else that can happen?
A physical change can happen. Take here, these ice cubes. They were once water, but now they're ice. But that doesn't mean they're not water anymore. They're still water, just but frozen. A chemical change is when the substance is changed somehow, but it's still the original substance.
Okay, so can you rewind it? So what's the difference between a chemical change and a physical change?
A chemical change is when when a substance gets changed somehow and becomes a new substance. But a physical change is when a substance gets changed, but there's no new substance formed.
Okay, so a physical change, no new substance formed. But a chemical change, a new substance is formed?
Yes, you're on the right track.
Oh my god! Hey, what are you making for dinner, Seth?
Oh, I'm making some ice because that's all we can afford.
Again, alright. Wait. You mean ice and water?
They're the same thing, though.
No. Ice is solid, water is liquid. That's easy, right?
But ice is solid water. You see, water is frozen in these to make ice. So, because it's a physical change, you can tell when a physical change happens because it's either freezing or melting. Because they're the same thing if it's frozen or melted. Also, if like the shape is changed or the size is changed / shape is changed, that would be considered a physical change as well. Or if it was expected, that would be. Yes.
Okay, so you're telling me that any change to a substance that does not change the substance itself is a physical change?
Correct.
Holy crap, man. Man, that's crazy, dude. Are you a female or a man?
Honestly, I don't know.
So that's crazy. Wow. Okay, so what are some signs if I know it's a physical change or not?
Like I said, if it changes shape or size, like what else? If something is expected, then it would be considered physical change if it doesn't change the substance itself.
Oh, okay, so if I were to add like food coloring to it, it's expected color.
Yes.
That would be physical change, right?
Yes.
Okay, so if the shape is changed, if the shape is changed of the shape, or the shape is changed of the substance, and it's not a new substance, or if it's an expected color that's coming to the substance, then it's a physical change, right?
Yes.
Okay.
Like here, as you see, the state of matter is changed from a solid to a liquid, then maybe into a gas if we leave it on for long enough. Hands off! Dinner's not ready yet. You forgot about our other meal. The bread is done now.
What?
The bread. I made some bread for once because we can't.
Finally! Oh my god, happy forever. You hear that, boys? So that means
you're going to stop finding the.
I'm trying to work. So that means that so signs of a physical change, so signs of a physical change would be if the size changes, if the shape changes, or an expected color is added to that substance.
How is this related? You're learning about the difference between products and reactants. This right here is products because it's the products of how these reactants have changed. As you see, this is what goes in, this is what comes out. So, anyways, would anyone?
I know that. So this is what happens, okay? That's C6O2 plus C 6C. Why did I say 6C?
Excuse me, sir. Who are you?
Oh, I'm the new student.
Okay, sure. Next, we'll be learning about the law of
Yields C6H12 plus CO2 6O2. So that's how you do the.
Are you
class.
sure you're in the right class?
No.
Uh,
No, continue teaching me.
Okay then. Okay, so we're gonna learn about the law of conservation mass, which basically means what goes in has to come out. Nothing more, nothing less. As you can see, all of these come out here. Every single element. Yes.
Okay, so you're telling me every single element that goes in here must come out. Like no new element. Well, no new elements can be made, right?
Yeah, a new element must be made, but with these elements.
Okay, so no, you can't just add random elements out of nowhere. That goes into the
No.
mixture.
What comes in must come out. Nothing more, nothing less.
So, if that's 16 grams, is that 16 grams? Yes. Wow, that's really crazy.
That's 12.
So, class, as you can obviously tell.
But this is 12. Did you skip math?
So, guys, as you can obviously tell, that's 16. That's 12 grams of mass right here, and it always has to come out as 12 grams of mass.
Should I
It
do
can
the
never.
explaining?
It can never come out
Student?
as it can never come out more than. I hate you. You're the worst. You're the worst teachers to ever come to existence.
Sir,
Mother love me long time, long time.